Okay, today we are simplifying exponents using these properties in this table. Although it says we're doing logarithms, it's actually no logs today. And notice what this says. No calculator. So everything we're doing today needs to be done without a calculator because this will be on the no calculator part of the Unit 3 text. Now inside this box, this is just a refresher of our exponent rules. You've been seeing these since Algebra 1, so they should be pretty familiar. This first one, notice the bases are the same. And when the bases are the same, and you're multiplying, what do you do with those exponents? Add them. And for the next one, notice the bases are the same. When the bases are the same and you are dividing, what do you do with that exponent?
Subtract.
Subtract. And down here, what is this called? It's MN. Remember something called power to a power? So if it's power to a power, you multiply the exponent. So power to a power, you multiply. And the next one, this one's pretty important. Do not leave a negative exponent in your answer. To get rid of a negative exponent, you send it to the other side of the fraction. So I can make a to the negative m become a fraction by putting it over 1. So notice this up here in the numerator, so send it to the denominator, it becomes a to the positive m. And this next one, this is for rational exponent, and this is called a rational exponent because the exponent is a ratio or a fraction. So if the exponent is a fraction, you can convert it to radical form. And this number a is your base, m is your power, and n, the bottom number, is the root that you take. So the top number is the power you raise it to, and the bottom number is the root that you take. And the way to keep it straight, think about a plant. Where are the roots located? Top or bottom? Bottom. So the root can be the bottom number. So notice that we're taking the nth root, so n is the root number that you're taking, and m is the power that you raise it to. Or another way we could write this, you could write this as the nth root of a, and after you take that nth root, raise it to the m power. So you can write those either way. And this last one will save you lots of time on your homework on one problem in particular, if you remember the rule that any number to the 0 power is equal to 1. So anything to the 0 power is 1. Okay, so let's get started. These will go pretty quick. So we do have 22 examples, but they're pretty short and sweet for the most part. Okay, problem number 1. Notice the bases are the same. So the bases are the same. Keep the base the same. And when you're multiplying, what do you do with the exponent? Add them. So 2 plus 3 is 5. Now, if it's something small, go ahead and simplify it further. So 3 to the 5th power, we have to figure out what 3 times 3 times 3 times 3 times 3 would be.
243.
You did that without a calculator? Good. Most of us know that 3 to the 3rd power is what? 27. And 27 times 3 is 81. And 81 times 3 is 243. I'll go ahead and circle it so you know what was the answer. So the answer I would be looking for when I'm grading it would be 246. If it's simplified, simplify. Now, if it's something outrageous, a huge, crazy number, no, I would expect you to simplify that without a calculator. And we'll see an example where it gets pretty crazy, and I'll tell you to stop. Okay, so number 2. Notice the bases are the same, so keep the base the same. And when you're dividing, what do you do with that exponent? Subtract them. So it's 5 minus 2? 3. Don't leave it like that. It's simplified. What is 3 to the 3rd power? 27. 27. 20 more problems to go. Next one. Number 3. Notice the bases are the same, so keep the base the same. And when you're multiplying, what do you do with those exponents? Add them. So it's negative 5 plus 3. Negative 2. Now this is a no-no. Never leave a negative exponent with your answer. So to get rid of the negative exponent, send it to the other side of the fraction. So how do I change 4 to the negative 2 to a fraction?
1 over 4 squared.
Yeah, put it over 1. So 4 to the negative 2 is in the numerator. Send it to the denominator. It becomes 4 to the positive 2. So when it moves to the other side, the negative changes to a positive. And you are right, this would be 1 over 4 squared. And that simplifies, and 1 over 4 squared is? 1/16. So again, make sure you simplify completely. Next one. We are multiplying, but this time we have coefficients. So make sure you multiply the coefficients first. So what's 2 times negative 3? Negative 6. And then when you're multiplying your variables, multiply in alphabetical order. So multiply the A's together, then multiply the B's together. So when the bases are the same, and you're multiplying, what do you do with these exponents? Add them. So it's 2 plus negative 4. Negative 2. And then for the B's, what is 3 plus 4? 7. So A to the negative 2, B to the 7. Can I leave my answer looking like that? No, what's wrong with that answer? We have a negative exponent. So I'm going to make this to a fraction by putting it over 1. And what variable has a negative exponent? The A. So the only thing that needs to move to the other side is the A only. So the negative 6 and the B to the 7th stays in the numerator, and A to the negative 2, send it to the bottom, becomes A to the positive 2. So when it moves to the other side of the fraction bar, it changes the sign of the exponent. Next one, number 5. We have several things going on here. I see some exponents. I see addition. And then I see another exponent on the outside, which implies power to a power. So if you have multiple operations going on, just remember good old PEMDAS. And what does that P stand for? Parentheses. So we need to work inside the parentheses first. So we have addition and we have exponents. What do we take care of first?
Parentheses.
Well, we're working inside the parentheses, but inside the parentheses, do we do the exponents first or the addition? Exponents. So exponents come before addition. So simplify our exponents. What is 5 squared? 25. And what's 5 to the negative 3?
5 to the 1. 126.
1 over 125 to the negative 3 power. So I just took care of my exponents. Now I'm still working inside the parentheses. So now I need to do the addition. But in order to do this addition, what do I have to have? A common denominator. So this is 25 over 1, and this is going to get kind of messy, but it's not too bad. Could be worse. And what is the common denominator between 1 and 125? 125. So now, to figure out what the numerator would be, we have to multiply 125 by 25.
3125.
You did that in your head? Are you on the math team? Should be. Okay, so I can't do that. 5 times 5 is 25, 5 times 2 is 10, 10 plus 2 is 12. 5 times 1 is 5 plus 1 is 6, 25 for the first row. Put my 0 here, 2 times 5 is 10. Then 2 times 2 is 4 plus 1 is 5. And then 2 times 1 is 2. So that would be 5, 2, 11, and 3. She was right, 3,125. Plus 1 over 125. And now that I have a common denominator, now I can add the numerator. So 3,125 plus 1 would be 3,126 over 125 to the negative 3 power. Now, who remembers what you need to do if you have a fraction to a negative power?
Put it on the other side.
What do you mean put on the other side?
I don't know.
What do I do with that fraction?
Flip it.
Flip it. So 125 goes to the top, 3,126 goes to the bottom, and negative 3 changes to a positive 3. So if you have a fraction to a negative power, flip the fraction, and the negative power becomes positive. Now, technically, this should simplify. I technically need to cube the numerator as well as cube the denominator. But do I really want to do 125 times 125 times 125? No. If I don't want to do that, do I want to do 3,126 times 3,126 times 3,126? No. So if it's going to be really, really huge, just leave it like that. So that would be a perfectly fine answer. Just make sure you don't have the negative exponent with your answer. So if it's just going to be a crazy number without a calculator, don't do it. But over here, 3,125, yeah, you should be able to do that without a calculator. Okay, next one, number 6. What should we do first? Yeah, those exponents. So 4 to the negative 2.
116.
That's 1/16.
Plus 1/8.
Yeah, 2 to the negative 3 is 1/8. And that's to the negative 1 power. In order to add these, what do we have to have? Common denominator. What would the common denominator be? 16, so 1/16 is good to go. Instead of 1/8, what would that be? 2/16. Now that we have the common denominator, we can add those. So 1/16 plus 2/16 is 3/16. So the negative 1 power. And can I leave that negative exponent? No, so what's the shortcut?
16 over 3.
Yeah, 16 over 3 to the positive 1. And really, do I have to have the positive 1? No, so your answer is just 16 over 3. If you want to change it to a mixed number, you can. But when we get to the unit circle, we'll be having these improper fractions all the time. So just kind of get used to improper fractions. They're cool. Okay, next one, number 7. What is this called? Power to a power. So if it's power to a power, what do I do with these exponents? Multiply. So what is 6 times 3? 18. So the answer is x to the 18th power. Again, number 8, what is this called? Power to a power. So we need to multiply. And 2 times negative 3? Negative 6. Can I leave that as my answer? How could I rewrite that? 1 over 2 to the 6. Should I leave it like that? No. 2 to the 6, you said what? 64. 1 over 64. Next one, number 9. If you have a fraction raised to a power, everything in the fraction needs to be raised to that power. So that means the 1 needs to be cubed, and the 2 needs to be cubed. So cube the top, cube the bottom. Everything gets cubed inside the parentheses. So what is 1 cubed? 1. What is 2 cubed? 8. So your answer is 1/8. Okay, I want you to do number 10. Okay, number 10. What do I do about the fraction to a negative power? Flip the fraction. So 1/4, when you flip it, what does that give you? 4. And negative 4 becomes positive 4. So leave your answer like that. What's 4 to the 4th power? 256. Next one, number 11. Everything in the parentheses needs to be raised to the negative 2 power. But I want to rewrite this. I want to rewrite this as one big fraction. So if I were to rewrite that as one big fraction, what number would go on the bottom?
X,
X two,
oh,
or
3,
X squared.
Well, over here, this is x squared z cubed over what?
3.
One.
Technically 1. So really, if I multiply these, this would just be a 3 in the bottom, and everything else will stay in the top. So x squared z cubed stays in the top, and now it's raised to the negative 2 power. So I'm just making it into one big fraction there. So 3 in the bottom, everything else stays in the top. Now what do I do if I have a fraction to a negative power?
Flip it.
Flip it. So the 3 goes to the top, and x squared z cubed goes to the bottom, and negative 2 changes to a positive 2. Now everything inside the parentheses needs to be squared. So the 3, when you square it, gives you 9. And x squared squared, what is this called? Power to a power. So what do I do with these exponents? Multiply. So 2 times 2 is 4, and for the z, 3 times 2 is 6. So if it's power to a power, those exponents get multiplied. Number 12. Any suggestions on where to start number 12? What was that? Flip a fraction, we can do that. So the 6x to the negative 3y goes to the top, and 3x to the negative 2y to the 5th goes to the bottom, and negative 3 changes to a positive 3. What's your next suggestion? Yeah, we can flip the negative. And actually, let's go ahead and take care of this with 6 divided by 3. I'll make this 2 over 1. X to the negative 3, where does it go? To the bottom, it becomes x to the positive 3. X to the negative 2, send it to the top, it becomes x squared. And then the y's are good. What's your next piece of advice? Yeah, let's go ahead and divide out the variables. Let's get these down to 1, so there's less to have to choose. Where's the bigger x, top or bottom? Bottom. And what's 3 minus 2? 1, so that's x to the first power. And for the y, where's the bigger y, top or bottom? So your answer for the y is to the bottom, and 5 minus 1 is 4. And once you completely simplify the inside, then it'll be faster to cube everything. So what is 2 cubed? 8. And then the x needs to be cubed. And y to the 4th, when you cube it, power to a power, what do you do there? Multiply. It becomes y to the 12th. So 8 over x cubed, y to the 12th. Okay, number 13, these are the rational exponents. And if I go back to the beginning, here's my rational exponent, and that large number out front is your base. The top number tells you the power, and the bottom number tells you the root. So if you're given the rational exponent form, you need to change it to radical form. So if you have rational exponents, change it to radical form. So looking at number 13, what is the base? 25. So 25 goes on the inside. Now I have to figure out what root are we taking. So remember, the root is the bottom number of the fraction. So what root are we taking? The second root, but do we normally put a 2 here? No. If it's the second root, it's understood to be the square root. So if it's a 2 for the root, you don't have to write it. But 25 is raised to what power? Yeah, the top number is your power, so that's 25 to the first power. Well, what's 25 to the first power?
25,
And what's the square of 25?
5.
5. So convert to radical form, then simplify. Next one, convert to radical form. So what is the base?
8.
8. What root are we taking? The cube root, and what power do we raise it to?
Second.
Second. Simplifying inside the radical, what is 8 squared?
64.
64, and what's the cube root of 64?
4.
4. Number 15, what is the base? 16, what root are we taking? Square root, and what power do we raise it to?
-7.
-3. Now, is that going to be helpful? No. Remember I told you there's another way you could rewrite it? And let's rewrite it the second way. So the second way would be to take the root of the base, and after you take the root, then worry about the power. So if it gets complicated without a calculator, do that. Take the root first, and then raise it to the power. Now this will be a lot simpler, because I know the square root of 6 is what? 4 to the -3. And how can I rewrite 4 to the -3? 1 over 4 cubed, which is 1 over 64. Number 16. What should I do first?
1.
Yeah, flip your fraction to get rid of the negative exponent. So it's 1 over 27. When you flip it, what does it give you?
2.
27 to the positive 2/3. I want you to do 16. What's the base? 27. What root are we taking? Cube root. And then I could raise it to the power, which is 2. Because I don't want to do 27 squared and then try to figure out what the cube root is. So just do the root first and then power it. So the cube root of 27 is 3, and 3 squared is 9. Okay, now we're going backwards. Now we're given the radical form. Now we have to write it with that rational exponent. So looking at number 17, what is the base? 2a. The base is what's under the radical. So that's 2a. And what power was it raised to? Or hang on, before we do that, we have the 1 out top first. So our base is 2a. If it's more than 1 item, so it's like if it's a variable with a coefficient, what you need to do is make sure that base with a coefficient and variable is in parentheses. So there's my base, it's 2a. It's in parentheses because the variable has a coefficient. Now what power did I raise it to?
3.
They raised it to the 3rd power, so the power goes on top. And what root did they take? 2. Now for these, I don't want you to leave a fractional answer. I want to see base, power, and root. I don't want anything extra. So we need to get rid of this 1. So how could I do that?
Swap it.
Swap it. So if I move this to the other side, instead of positive 3/2, what would it be?
-3.
Negative 3/2. So that would be the only time it would be okay to have a negative exponent in your answer, and that's when you're rewriting it from radical form as a rational exponent. So a rational exponent you can leave as a negative if you're converting. Next one, number 18. What do you think the base was?
AB.
AB. And what power were the A and B raised to?
3.
The 3rd power. And what root are they taking?
4.
4. So again, if you have more than one item, make sure you use parentheses for that base. Okay, these last four, it says solve with like bases. So we need to get a common base. So notice for 19, we have a base of 4 and a base of 16. What would be a common base I could use for 4 and 16? 4. So the left side is good. But the right side, instead of 16, that would be 4 to what power? Squared, yeah, 4 squared. And then after the 16, the exponent is 3x. Now, what does this symbol right here mean? Equal. So if the bases are equal, what does that tell me about the exponent? They are equal as well. So what we need to do is set the exponents equal. So the exponent for the left side is 2x minus 1. And the exponent for the right side, we have 2, and this is power to a power, so we would multiply. For the first time, I'll write the multiplication out. From here forward, I won't. And when you multiply your power to a power, what's 2 times 3x? 6x. Solve for x. Subtract 2x to both sides. So negative 1 equals 4x. Divide both sides by 4. And what does x equal? Negative 1/4. Now if you have something like negative 2/8, make sure you simplify it. And number 20, what would be a common base between 27 and 9? 3, because there's not a power of 9 that would give us a 27. So we'll have to use a base of 3 here. So for 27, that would be 3 to what power? The third power, 3 cubed. And for 9, that would be 3 to what power? Second. Now if the bases are equal, what does that tell me about the exponents? The exponents were equal, so that means 3 times x plus 3 needs to be set equal to 2 times x minus 6. If it's power to a power, they need to be multiplied. And when I distribute the 3, what do I get? 3x plus 9. And when I distribute the 2, what do I get? 2x minus 12. Subtract 2x to both sides. 3x minus 2x is 1x plus 9 equals negative 12. And what's the last step? Subtract 9 to both sides. So that gives us x equals what?
Negative 21.
Negative 21. Last two. Okay, number 21. We have to get a common base, and what would the common base be? 5. So instead of 1/5, that would be 5 to what power? Negative 1. Instead of 1/25, that would be 5 to the third power. And now I'll go ahead and just do my distributing. Because if the bases are the same, what do I know about the exponents? Yeah, they're the same too. So if I distribute this negative 1, what does that give me? Negative x plus 2. And when I multiply these, this is actually 3 over 1. So what does that give me? 3x over 2. How do I want to solve this? Do I want to do a proportion, or do I want to just divide 3x by 2? Yeah, we can multiply both sides by 2. So when I do that, we'll have to distribute the 2 over here. So it's 2 times negative x. Negative 2x, and 2 times 2? Plus 4. That equals 3x. What's next? Add 2x to both sides. So 4 equals 5x. And the last step? Divide both sides by 5. And what does x equal? 4/5. And the last one, number 22, we need to get rid of that 20 up front. How do I get rid of the 20 up front? It's being multiplied because of the parentheses, so we need to divide both sides by 20. So that gives us 1/2, so the x over 3 equals 5 over 20 is 1/4. Okay, how would you solve that one by getting like bases? What's the like base? 2. So instead of 1/2, this would be 2 to what power? -1. Instead of 1/4, that would be 2 to the -2 or negative squared. And if the bases are equal, what does that tell me about the exponent? They're equal as well. And I'm going to make this x over -3 equals -2. Multiply both sides by -3. And what does x equal? 6. Now on your assignment, make sure you're not using a calculator. If it gets too crazy, just leave it alone. Like, don't do 3,126 cubed. But if it's something like 5 to the 5th power, yeah, I would expect you to do that. And make sure you show your work, no credit.